All right, guys, welcome to Lesson 1. We're going to be reviewing how to solve equations today. You might want to write down on your notes this title here. You don't have to write down the whole thing. I would just put 1.1. The first one represents the unit we're in. The second one represents the lesson we're in. So just put that at the top of your paper at least so you know what lesson we're on at least. So today's topic, like I said, is we're going to be learning how to solve equations. So pause the video here and write down this slide, and when you unpause it, we will continue. So we'll be solving one-step equations, two-step equations, and then multi-step equations today. And notice I put today we will review because this is stuff that you have already seen, but it's good to review it. So hopefully today's not too bad for you. So let's begin solving equations. Now as I go, if you need to pause the video to write down the notes, that's fine. You don't have to write down word for word what I put, but you can abbreviate it or put it in your own words to make it shorter. It's up to you, but just make sure you do have the same information recorded, okay? So to solve an equation means that we want to find the unknown value in an equation. So like this one here, I want to know what x is equal to. That's the one that I don't know. The unknown value is represented by a letter, and that letter is known as a variable. So to solve an equation means I want to figure out what does x equal, right? The way that we find that unknown value is by getting the variable by itself. So I would like to get rid of this 5 here and this 2 somehow. And if I do that, I can find out what x is equal to. I know what 2x minus 5 is equal to. 2x minus 5 is equal to 6. But I want to know what just x is equal to. So I need to get rid of the 2 and the 5. We get the variable by itself by doing what's called inverse operations. And that's just a fancy way of saying doing the opposite. Okay, so for instance, let's take a look at this example here. A plus 5 is equal to negative 9. Well, I want to get the a by itself. So the first thing I'm going to do is I'm going to ask myself, what do I want to get rid of? I want to get rid of the 5, right? So I ask myself, well, what is the 5 doing to the a? Well, it's being added to the a. So I'm going to get rid of that 5 to get the variable by itself. I'm going to do the inverse operation, which means I'm going to do the opposite. So what is the opposite of adding 5? The opposite of adding 5 would be subtracting 5. Now, that's okay. You're allowed to do that so long as you do it on both sides of the equal sign. So I put minus 5 on the left. I'm also going to put minus 5 on the right side of the equal sign, and that keeps this equation balanced. An equation is claiming that both sides are the same. So you're allowed to do whatever you want to one side so long as you do it to the other to keep it balanced. And now we just need to see what results after we do that to both sides. The a is still there, but since these are opposites, these cancel. They're gone now. And negative 9 minus 5 is negative 14. Now, if you have a hard time with your adding positive and negative numbers, go ahead and use a calculator. I'm fine with that. Okay? But in this case, it would be a equals negative 14. So there you guys have it. To solve an equation means get the variable by itself. You do that by doing the inverse operation, which just means doing the opposite. So once again, you don't have to write down this whole slide word for word, but you should write down all the ideas that are present. If you want to do it in your own words or abbreviate it somehow, you're welcome to do that. All right, so we're going to look at some examples now. Now, when it comes to the examples, I would encourage you guys to write down the instructions. So you definitely want to write this down. And then also the problem. And then, of course, you want to show your work completely. The examples are really important because those are what you, remember, we're not going to have a textbook in this class. So your notes are your textbook. You want to write your notes in such a way that you're able to look back on these 3 weeks from now or 4 weeks from now, and you would be able to read your own notes and figure out how to do it. So make sure that your notes are that clear to you. So make sure you take really good notes on the example problems. All right, so let's begin here. What do I need to get rid of first? I want to get x by itself, so what do I need to get rid of? I need to get rid of the 20. If I get rid of that, then x will be by itself. Next question. What is the 20 doing to the x? It's being added. So how do I get rid of the 20 then? I do the opposite. I subtract it. And whatever you do to one side, you do to the other. So I'm going to minus 20 on both sides. 20 minus 20 cancels out because they're opposites. The x comes down. The equal sign comes down. 24 minus 20 is 4. And now I have x by itself. X is equal to 4. Notice the questions I went through. What number do I want to get rid of? In this case, I wanted to get rid of the 20. The next thing I ask myself is, what's it doing to the x? In this case, it was adding to the x. After that, we do the opposite on both sides. Okay? Now, this is what's called a one-step equation. And the reason for that is because I only had to do one thing to get the x by itself. I really just had to subtract the 20 on both sides. So, one-step equations, what do? Find what number you want to get rid of, ask yourself what's it doing to the x, and then do the opposite on both sides. All right, let's go ahead and take a look at number 2 here. I'm going to do 4 examples, and then you guys will get some practice problems. So, what number do I want to get rid of is my first question. I want to get rid of that 12. Second question, what's it doing to the n? Well, it looks like it's being subtracted from the n. Third question, or it's not really a question, it's a command to do the opposite. So instead of subtracting 12, the opposite is adding the 12, and whatever you do on one side, you do on the other. All right? So negative 12 and positive 12 are opposites, so they cancel. Bring down your n, bring down your equal sign. Negative 9 plus 12 is 3. Once again, if you're having a hard time with adding negatives and positives and stuff like that, just use a calculator. That's totally okay. All right, let's move on to number 3. Question 1, what do I want to get rid of? I want to get rid of the 10. All right, what's it doing to the n right now? What does the 10 do to the letter n? Well, when they're right next to it, that means they're being multiplied. So what is the opposite of multiplication? It is division. All right. Now, in algebra, we show division with fractions. So I'll show you what I mean by that. In algebra, we show division with fractions. So right now I've got 10 times n. I want to do the opposite to get rid of that 10. The opposite of multiplication is division, so I'm going to divide. And I show my division by making a fraction. So I'm going to put this over 10. And that makes a fraction. Once again, though, whatever you do to one side, you do to the other. So in this case, these are going to cancel. Now, just as a side note, 10 divided by 10 equals 1. So if you have 10 over 10 n, that's really just 1 n. And as you guys may remember in Algebra 1, you don't have to write the 1 in the front if it's just a 1. So you can just put n. So I'm going to cancel these, but they actually don't just go away. They actually leave a 1, just so you know. And that's important because over here, they don't just go away. You can't just leave nothing there. 10 divided by 10 is 1. So you could write your answer like this if you want to, but since there's a 1 in front of the n, we don't have to write the 1 in front of the n, but you have to have the 1 on the other side. So that means that n is equal to 1. All right, let's go ahead and take a look at a 4th example here. What number do I want to get rid of? I want to get rid of the 5. Well, what's it doing to the v? Well, it's underneath of it. And as I mentioned on the last problem, that's a fraction, right? Well, that means division. So that means that v is being divided by 5? V is being divided by 5. Okay? Just so you guys know, the one that's on top is the one that's being divided by the one on the bottom. Okay? So it would be wrong to say 5 is being divided by V because 5 is on the bottom. What's going on here is the V is being divided by the 5. All right, so what number do I want to get rid of? I want to get rid of the 5. What's it doing to the V? It's dividing it. So what's the opposite of division? The opposite of division is multiplication. So I'm going to multiply by 5. And whatever you do to one side, you do the other. Now, this is like 5 over 5 here, which, as we said before, is just 1. So you end up with 1 times V in that case. And 5 times 7 is 35. And once again, you don't really need to write the 1 in the front of a V. So we did an example where you had a plus, a minus, a multiplication, and a division. And so those are all the different types of one-step equations that we're going to look at in this first example. All right, so I'm going to give you guys some to practice here. Now, this is what I call student practice. With the student practices, I do want you to work on them, but it's not quite as important that you get really thorough with how much you write, because this is just an opportunity to practice what we just did. I do want you to at least work on it. Now in class I can check that whenever I'm walking around and checking work, but in the notes, just scribble something on there to get the answer. So pause the video here and do numbers 5 through 8, and when you unpause the video, I will have the problems worked out for you so you could check your work. All right, guys, so there's the solutions. Check your work. If you didn't get it right, maybe write down a question. Feel free to talk to a neighbor if you need to figure out what maybe you did wrong if you don't understand. But we are moving on to the next set at this time. So I said today that we would be talking about one-step equations, two-step equations, and multi-step equations. We just finished talking about one-steps, and now we're going to move on to the two-step equations. Now, the important thing to know about when solving two-step equations is you're going to have 2 steps, and you want to know which one is first. So here's an important note that you probably want to write down. Addition or subtraction will come before multiplication or division. Okay? Addition or subtraction will come before multiplication or division. Now, technically, you could do it in a reverse order, but it actually makes things a little bit harder if you don't do it in this order. So I'm going to stick with this order for the two-step equations. All right? So here's my variable. Now, my question is, what do I want to get rid of so that k is all by itself on the left side of the equal sign? Well, I need to get rid of the 5. And I also need to get rid of the 10. So I've got 2 things to get rid of this time, and that's why it's a two-step equation. Now, what is the 10 doing to the k? Well, it looks like it's being subtracted from the k. So I'm going to need to add 10 to get rid of the 10. But what about the 5? What's the 5 doing to the k? Well, since it's right next to it, that means it's being multiplied. And the opposite of multiplication is division. So to get rid of that 5, I'm going to do the opposite of multiplication, which is divide by 5. Now, which one of these do I do first? Do I divide 5 or do I add 10? Well, over here it says addition or subtraction should come first. So we're going to do this first, and then we're going to do this second. Okay? So let's do that. Here we go. 5k minus 10 equals 35. So we said we were going to add 10 first, and then we were going to divide by 5 second. And there you have it. So that's a two-step equation. We added 10 first, and then we divided by 5. All right. Let's go ahead and take a look at another example. I'm going to do 9, 10, and 11 are going to be teacher examples. So I'm going to do number 11 first, and I'll go back and do 10 because 10 is kind of a weird problem. So I'll go back to 10 in a minute. For now, let's take a look at number 11. So I have an equation here. I want to solve for k. I want to get k by itself. The 7 is a positive 7 being added to the k. Okay. So since it's a positive 7, I want to subtract 7. And then I also need to get rid of this 2. Well, that 2 is dividing the k. So to get rid of that, I'll do the opposite, which is multiply by 2. And we said that we do addition or subtraction first and then multiplication second. Okay? So let's go ahead and see how that pans out. All right, so we said we were going to subtract the 7 first. That leaves me with 3 equals k over 2. And then we were going to multiply by 2 second, which leaves me with, these basically just make 1k. And this is 6. And once again, you don't have to write the 1 in front of the k. So k equals 6. All right. Now I want to show you a weird two-step equation. And it's weird because anytime you have a plus b over c, something like this, you need to multiply first. Okay? Now remember how I told you addition or subtraction comes before multiplication division? I also said, well, you can do it the other way, but usually it makes things harder. Well, with this type of equation, when it looks like this, it's actually easier to do the multiplication first. So let's take a look at how to do this problem. So we have a negative 10 being added to the r, and we have the 2 dividing into the r. It's actually also dividing into the 10, and that's what makes it kind of weird. But we could lay that aside for now. So to get rid of the negative 10, which is being added to r, I need to subtract a negative 10. Now, just so you guys know, when you're subtracting a negative, that's really the same thing as adding 10. Okay? If you ever have a negative number and you subtract it, double negatives make a positive. So we want to subtract a negative 10, but it's basically adding. So since an easier way to think about it is, since this is a negative, just do a plus. Okay? So we're going to add 10, and then we're also going to, what's the 2 doing to the r? It's dividing it because it's in the bottom. So we would multiply by 2. Now, once again, this is a weird one. So we're going to do the multiplication first on this problem. So I'm going to put this whole thing in parentheses. I'm going to put times 2 on this side and times 2 on this side. That's how I would show my work for these types of problems. Now you have 2 over 2, which is 1. And you know we don't need to write the 1, so we'll just go ahead and cross that off. And now we need to subtract the negative 10, but that's really just the same thing as adding 10. And that leaves me with r equals negative 12. Okay? So those are two-step equations. let me bring some up for you guys to practice with. All right, so go ahead and try these three problems, 12, 13, and 14. This is just for you to practice with. Show your work and see if you get the right answers. Pause the video. When you unpause it, I will have it worked out for you. Okay, guys, so the answers are 16, 14, and negative 11. If you didn't get those, check your work here, and if that doesn't help, maybe ask a neighbor you're sitting next to, see how they did it, ask them to explain it to you. And we'll go ahead and move on to our last thing. So we said we're learning three things today. One step, which we did in the beginning, two step, which we just completed, and now we're going to look at multi-step equations. And these are called multi-step equations because they have more than two steps. So we don't know how many there'll be, sometimes 3, sometimes 4, sometimes more. It just depends. With these types of problems, first, usually, you're going to do any kind of distribution that you can. Now, if you guys don't remember what that means if you have a number outside a set of parentheses, you're going to multiply it inside the parentheses to each number. Okay, that's distribution. You're going to do that first. Okay? The next thing you're going to do is you're going to move the smaller variable. Well, actually, let me take that back. You're going to combine any like terms if possible. After that, you're going to move the smaller variable. After that, you're going to follow the two-step equation process. So there are 3 new steps when you have a multi-step equation. Sometimes you'll do all of them. Sometimes you might do one of them. But here they are. The first new step is to distribute. The second new step is to combine like terms that are on the left and to combine like terms that are on the right. Now I'll show you what that one means when we get to a problem that has it. And then number 3, you move the smaller variable. And I'll show you what that means when we get there as well. But those are your 3 new steps. And like I said, not every problem is going to use all of those steps. You just have to recognize when they need to be done, and then you do it. And if they don't, you just skip it. But after you've done those 3 new steps, you should have a 2-step equation left, and you just follow those steps. Okay? So let's begin. Now, just so you guys know, I've taught in the past to help people remember this. D, C, M, and I just call this S for solve. DCMS, don't call me stupid. That's how I teach kids to remember that process, DCMS, if that's helpful to you. I say, don't call me stupid, and those are the steps. I don't know, just something to help you remember it if you want to. But let's begin. So step 1 is to distribute. Do you guys see in this problem anything that looks like this where you have a number outside a set of parentheses? I do. It's right here. So we're going to distribute. I'm going to take this 8 and I'm going to multiply it into the parentheses. And that's going to leave me with negative 8v minus 40. And this other side is going to stay the same. Okay? Got to watch your signs with these problems. A negative 8 times a positive 5 is a negative 40. All right, so that's step 1. Step 1 is accomplished. Let's move on to step 2. We want to combine like terms. Now, this step we don't have to do, and here's why. Like terms are two numbers that have the same variable, or maybe they're just both numbers without a variable. On the left side, I don't see any like terms. I have an 8v, but there's nothing to combine it with. There's no other v's on the left side. I also have a 40, but that's just a number, and I don't have any numbers to combine it with that don't have a variable. So these are not like terms, and I cannot combine them. So we're done with that. And the same thing is happening over here on the right. There's no like terms. So I can skip this step. Okay? Now, some of you guys might be thinking, but Mr. Bailey, aren't these like terms? Yes, they are, but the thing is that they're not on the same side. You only combine like terms on the left, and you combine like terms on the right. Okay? All right, next step is to move the smaller x. And on this step, now we will start putting the things on opposite sides together. Or I said move the smaller variable. Now, which one of these variables is smaller? Negative 8v or positive 8v? Well, negative numbers are smaller than positives. So I'm going to get rid of the negative 8. Now, how do I get rid of this negative 8? Well, I'm going to do the opposite. This is where we do the inverse operation again. So since this is a negative 8v being put together with a negative 40, I'm going to add 8v to both sides. I do the opposite of the smaller variable. These cancel out, and now I'm left with negative 40 equals negative 8 plus 16v. At that point, you should have a two-step equation, which I do. And now we're just going to follow the steps for the two-step equation. I need to get rid of this negative 8 by adding it, and I need to get rid of this 16 by dividing it. Addition comes before division. And then division comes second. And there you go. So DCMS stands for distribute, combine like terms, move the smaller variable, and then solve means follow the steps for a regular two-step equation. All right, let's take a look at another example here. All right. Second problem for multi-step equations. All right, so step 1 is to do any distribution. Do you guys see any distribution? I do. We need to take this negative 6 here and distribute it into the parentheses. Notice I included the minus with the 6 because that's part of the number there. So we're going to distribute the negative 6. All right, let's see what we get as a result of that. Negative 6 times 8 is negative 48. And negative 6 times positive 6 is negative 36. And everything on this side is going to stay the same. All right. What is step 2? Step 2 is to combine any like terms that may exist on the left and the right. We do have some like terms this time on the left side. Do you see what they are? The like terms are the negative 5v and the negative 48. So we're going to combine those like terms. There are no like terms on the right side, so we'll leave that one alone. But on the left, we do have like terms. Here's how I show my work for combining like terms. And it's a good idea to show your work. Get rid of that line real quick. I draw an arrow from each one coming together at a point, and I'm going to put the result that comes from putting those together underneath the point. So negative 5 minus 48, that's negative 53 if you combine them. Now by combine, we mean add or subtract. Okay, we're adding and subtracting, we're not multiplying. So negative 5v minus 48v is Sorry, it's negative 53v. It's not 58. Negative 53v. Everything else just comes down the way it is. So the negative 36 stays, the 3v stays, and the 20 stays. So we've distributed. We've combined like terms. Now what do we do? What's the next step? DCMS. Distribute, combine like terms. What's next? It's move the smaller variable. Now, which one of these numbers is smaller? Is it the negative 53 or is it the 3v? Well, a negative is smaller than a positive, so we're going to get rid of that negative 53. Since it's a negative, we're going to add 53v on both sides. Notice that I put the 53 under the 3v because those are like terms. So those go away now. And I've got negative 36 is equal to 56v plus 20. At that point, you should have a two-step equation. So what do we do here? We moved the smaller x, or smaller variable. The smaller variable was 53, and I added it to cancel it off of the left side, and that moves it to the right side. So I moved the smaller area. So we distributed, we combined like terms, I've moved the smaller variable. Now we should have the last step, which is to solve a two-step equation using the steps that we talked about for that. So to get the v by itself, I'm going to need to subtract the 20 and divide the 56. So let's do that. And I get v equals negative 1. All right, and there's our steps that I said we would do. All of them are there this time. D, C, M, S. All right. I'll do one more example before I set you guys loose on some practice problems. All right, now I included this one because there is distribution here. It just doesn't look like there is. As we said earlier, distribution looks like this, right? Where there's a number in front of the parentheses. Well, we do have parentheses, but it doesn't look like there's a number in the front. But there is. It's a invisible 1. Those ones are sneaky. They like to hide. So the first thing I might encourage you guys to do is to rewrite the problem like this. If you ever have a pair of parentheses with just a negative, I would put a 1 there. It's helpful. Now, if you don't want to, you don't have to. If you just do it mentally, that's fine. But that's what I would do there. Okay? After that, we're ready to do our steps as usual. All right? So we're going to start by distributing the negative 1. Negative 1 times negative x is a positive x. Negative 1 times negative 5 is a positive 5. So we distributed. All right, are there any like terms to combine? On the left side, is there anything I can combine together? No. On the right side? No. So we can skip the combining like terms again. Now we want to move the smaller variable. All right. So I have a negative 4x and a positive 1x. If you want to put the 1 there, you can, because remember there's that invisible 1 in front of the variable if it's not there. What's bigger, what's smaller, a negative 4 or a 1? Well, the negatives are smaller than positives, so I would add 4, do the opposite, right, on both sides. Just so you guys know, anytime you're moving a variable, it's usually going to be adding or subtracting. All right, so we've done the distribution. There was no like terms. We've moved the smaller x. We're ready for the last step, which is to solve the two-step equation. So I want to get the x by itself. So I need to divide by 5 and subtract this 5. And we do the subtraction first. And I get negative 4. All right. So just keep in mind, sometimes you won't have to do every step. You may not have to distribute. If you don't have parentheses, you probably don't have distribution, so you can skip it. We saw a few examples where you don't have to combine like terms. You may not have to move the smaller variable. If you only have a variable on one side of the equal sign, you don't have to do that either. So the first 3 steps are optional. You may or may not have to do them depending on whether it's necessary or not. Okay? The 4th step, though, should get you there with a 2-step equation every time. So here's some practices for you. So pause the video here and do numbers 18 through 20, and when you unpause it, I will have the solutions available for you. Okay, guys, so there's our answers. Number 18, you should have gotten negative 1. Number 19, you should have gotten 8. And number 20, you should have gotten negative 2. Check your work here, and if that doesn't help, maybe check with a neighbor and see if they can help you a little bit. All right, we'll have some homework this weekend, so go ahead and do that, and then we'll see you guys in class. Make sure you upload this before the end of class today, and homework will be due before the beginning of class on Monday. We'll see you guys then. Bye-bye.